Okay, 54 part E from the chapter review. So remind yourself of this problem. I'm hoping you're okay with A, B, C, and D. I'm hoping you realize there are parts F and G on the top right. I know it's really blurry to read here, so you can look on with your using your own book. And I'm looking at part E. It asks for the equation of the tangent line to the graph of G to the graph of G at x equals -1. Okay, this is really just based on point slope form. And let's write down point slope form using calculus. Y equals the derivative at 1 times x minus 1 plus g of 1. Again, this just is y equals m times x minus x sub 1 plus y sub 1. That's all that is. Let me cross that out. Okay, y equals g prime of 1. The graph given is the graph of g prime of 1 using the first fundamental theorem of calculus. So g prime of 1 is the same as f of 1. And then f of 1 on this graph is, what am I looking at? I'm sorry, it's not 1, it's -1. I apologize. F of -1 or g of -1 is just 2. So that's the y value. G prime of, and again, I wrote down +1. It's -1, -1, -1. So G prime of -1 from the graph I just showed you is 2. X, this is going to be +1, +1. G of -1, you found that in part C. G of -1 is -pi. And that's it. That's the answer for E. Let's go on to F. Someone asked for F as well. F is looking for the x-coordinate of the points of inflection. So this is the graph of G prime. We want the x-coordinates for the point of inflection. It's where the graph of G prime changes from increasing to decreasing or vice versa, causing G double prime to change signs. So I need local extrema on here, peaks and valleys on here. So the first time my graph changes from increasing to decreasing is at -1. That's an inflection point. And the second time it changes from decreasing to increasing is at x equals 2. There's two inflection points at -1 and 2 because those 2 points would produce a sign change in the second derivative. All right, part G is a little different. Part G is looking for, so let me continue. This is what the problem said. G of x is the integral from 1 to x, f of t dt. And part G is asking for the range of the graph, the function G. Again, this is how G is defined. It's defined as this integral. So the range of G are the y values, the minimum and the maximum. So let's look at this. Again, G represents the integral from 1 to x. That's what it represents, from 1 to x. So we're just looking for like the smallest area I can produce, or the largest area I can produce. So if I go from, let's say, 1 to 3, it'll be a negative value. 1 to 4, it'll be a negative value as well. If I go from 1 to 1, it's 0. If I go from 1 to -3, that's going to be negative as well because I have to switch the sign. So I'm just seriously playing with right now my possible options. I'm looking at the integral from 1 to -3. And again, we would have to switch the sign, the limits of integration, and throw the negative sign in and bring this down. And then this would represent, this portion right here is just the area of the semicircle. And then the area of the semicircle is just 2 pi. That's the area of the semicircle. And the negative just makes it to be -2 pi. I'm just playing around with some values. If I go from, again, 1 to 1, that's going to give me 0. Okay, I'm looking at my possible y values, my possible answers to when I evaluate the integral. If I go from 1 to 2, f of x dx, we just talked about this. I showed it to you. If I look at like 1 to 2, it's some negative answer. It's the area of that triangle. If I go from 1 to 3, so I'll do 1 to 3 because that's a larger triangle. 1 to 3, it's below the x-axis, so it will be negative for 1 to 3. The base is 2. The height is 1. So the area ends up being just 1. Okay, all right, we'll do one more. It's the integral from 1 to 4, f of x dx. Again, I'm just supposed to find the smallest y value and largest y value because that's how you write the range of a function. If I go from the integral from 1 to 4, that's going to be negative also. But again, this is the smallest y value. And I'm never going to get a positive answer. I'm not, because I'm stuck with going from 1. I'm never going to get a positive answer, so my biggest y value will be 0. So here's the range of g from negative 2 pi to 0. That's the range of g. And again, I just sort of like, played around with the upper limit and I changed them and I looked at the possible answers that I would obtain. This is my smallest y value and that's the largest y value. All right, last one is number 59. And I'm glad that many of us asked for number 59. Number 59 is a really good problem to do. And so here's me starting 59. Bear with me, I just need to write down the information that was given. 59, they gave you f prime of x. They gave you a random integral, and I promise it's not random. It's from 1 to 2, f of x dx equals 14. F prime of x has a's and b's. It's ax squared plus bx. And that they also told you in part B that f prime of 1 is negative 6. And that they told you that f double prime of 1 is positive 6. Let me make sure I wrote that right. Yes, and our job for 59 is to find f of x. That's our job. I promise all of these pieces of information will help us find f of x. Obviously, once we find f prime of x, we can go find the antiderivative to find f of x. Now, I can't really work with a's and b's, so let me get started. If f prime of 1 is negative 6, I'm going to plug in x is 1. I'm going to put it equal to 6, negative 6. So f prime of 1 is negative 6. So this right here is negative 6 equals 1 squared, which is 1. Here's the a. B is what I'm going to leave, and x is 1. So here's my first system of equations. This piece of information is going to give me the second system of equations. But before I can utilize this piece of information, I need to find the second derivative. So if this is f prime of x, let's do the power rule. This is the second derivative. Let's plug into here. When x is 1, this entire second derivative equals 6. So 6 equals x is 1, 2a plus b. This is my second equation. Do a system of equations with using these. Pause the video and do a system of equations using these two. And you should get, when you're done, you should get for a, you should get 12 when you do a system of equations. A is 12 and b is negative 18. That's what you should get. Okay, so let me write down what my final f prime of x is using the a's and b's I just obtained. So f prime of x is a is 12, x squared, b is negative 18, and then x. This is my final f prime of x. Let's use this to come up with f of x. We've got my first derivative, we're going backwards, and we're coming up with the antiderivative. Plus c, because I might forget it and you might forget it. If this is a quadratic, it's going to be x cubed. Obviously, this is not enough. This is going to produce 3x squared, and I don't want 3x squared. How do I go from a 3 to a 12? Let's put a 4 up here. Check your work. Take the derivative. 4 times 3 is 12. Okay, if this is a linear, it's going to be a quadratic. Obviously, this is not it, because this is going to produce a 2x. I don't want a 2x. I don't want a 2x. I want an 18x. So a 9 would take me to the 18, and there's the plus c. Okay, guys and girls, notice this is the information from part 1 in the problem. These two things were from part 2 of the problem. We have yet to use this. This is going to help you figure out what your C is. So, f of x is this function I have. Let me go set up my integral from 1 to 2 using this cubic. Yes, with the c, with the constant. And I know this equals 14 because that's what the problem said. Okay, guys and girls, you're going to do the second fundamental theorem of calculus. You should pause the video, find the antiderivative yourself, plug in for x a 2, plug in for x a 1, subtract them, and I think I've said too much, so let me actually do it. So I'm going to find the antiderivative of this. This is me doing the left side. The left side, if that's a cubic, my answer is going to be a quartic, and x to the 4th, that would work, because the derivative of that is 4x cubed. This is going to be a cubic, and I need it to be a 3, because 3 times 3 is 9, and then it'll be x squared. This is a constant. I don't know what it is, but the antiderivative of a constant, imagine if this was a 5. If this is a 5, then the antiderivative would be 5x. If this is a 10, the antiderivative would be a 10x, but the antiderivative here is a cx. Such that when I plug in 1 and 2, and when I do all the math out, I get 14. So let me actually do the second fundamental theorem of calculus. And I'm not doing it to find my answer. I'm doing it to solve for c. Let's plug in, anytime you see x, let's plug in 2. 2 to the 4th minus 3, 2 cubed, plus c times 2. So 2c minus, do not forget the parentheses. Plug in 1, 1 to the 4th power, minus 3, plus plug in 1 for x, so I just get c. Okay, I'm going to let you stop. I'm sorry about that awkwardness. I'll erase this, equals 14. I'm going to stop and let you finish. Your job is, because the only thing you're missing here is c. That's the only missing term. You can go find c now by doing some arithmetic. I'm glad that we asked for this problem. It had some algebra 1 system of equations. You had to find the derivative, but you also had to find the antiderivative, and then you also had to apply the second fundamental theorem of calculus in an unusual way. We usually find it to get the 14, but they gave us the 14, so we used the theorem to find c. Okay, that's it. And I'm sorry if your questions were not addressed. I try to address questions that most people asked for. If there's 2 or more people who asked for a question, then I did make a video out of it.